This video is to talk about how we will do the switch statement in assembly language. Yeah, you all remember in C++ we have the console menu-driven programming. You can have the user to enter UEL, TVR, or Q to have the selection. So every time then we just come back to the menu until user say quit, so we finish, right? So you all remember if we have those menu-driven programming, those menu-driven table, actually we will have the input from the user. Then we use the switch statement. According to the switch statement user's choice, we have the different cases. So then we call different function to fulfill the selection from the user. So it's possible we can do that in assembly language. Yes, we can do that, but then we will see how should we do that. So here, I just want to show you the example on how we will do that. So our goal is we will have a table-driven selection to have the user to make a choice. So according to user's choice, so then we will give them the corresponding result. But here, this one actually is what I want you to do for the homework assignment. But the example, I will choose a little simple one to show you. So we will make our console output look a little easier. So actually our console only look like this. We just display to the user, say, press capital A, B, C, or D. Okay. So actually here is we will get user input. So after user enter B, so I display process B. If user enters C, I display process C. So this one actually we just want you to show you the structure, how we will make a table-driven programming. So the same thing, when user enter A, we will call procedure A procedure. So remember, when we do in C++, remember here as your menu, right? After the user enter, actually in your switch statement, you find out the match one, you just call a function. So the same thing here, what we want to do is, we want to give the user to enter the choice with the letter. So after the letter, actually I just right away to execute that function. But in assembly language, we don't call function, so we call procedure. So in order to fulfill this task in assembly language, actually the first thing we need to do is we need to create a table of the procedure of set. What does that mean? That's mean here. I need to have a table that look like this. Actually, my table kind of is an array. So this array contains what? The first value is a byte. So this byte is the user input, like the case in my C++ in the switch. So once I match, I find out user's enter is A, right? So the next 4 byte actually is the location for my procedure. So after I find out user's match is A, I just call this procedure. So the same thing, B, I call this procedure. C, I call this procedure. Okay. So one thing is in assembly language, we can try to go to call a procedure. We use this way. We're using the call, right? Remember, we can call a procedure. However, if your procedure is you only know the procedure of set, that means your address. So if your address you know, so then we don't call procedure name. Actually, we're using another PTR, another pointer. So this pointer called near pointer. So near pointer actually is kind of a pointer to convert this offset, because remember here is only the address for the procedure. So then your near pointer will convert this procedure become the the address for the procedure become the real procedure we want to code. Okay, so you will feel weird. Where is the address for the procedure? So that's why actually I need to show you is, actually here's our procedure. Okay, we call the process underscore a PROC. Actually, this one is the beginning for the location. Remember, all your procedure, you have your keyword PROC and P, right? But here, even that's a keyword we know. But this one is the location. They were the first place, first instruction they will execute. But this process A, just like, did you remember your function in C++? The function have a location as well. That's why your procedure name actually is the reference to bring you to this code block. So this process A, you look like is the procedure name. But actually for this one, they also have a reference location. So if using the process A is procedure name, right? But when we save, that's in a table. If here I create a array, actually you can say that's array or not. But usually we say array is we consider array with the sequence of the same data type value. But here is I just call case table. The case table actually I always follow the order is what? I have a byte first. So then I follow by the 4-byte memory address for the procedure. So how do I get the memory address for the procedure? You just need to declare the D word, 4-byte. So then your procedure name. So then they will give you the address to save in here. So that's what we call the case table. So this case table you just see followed by the case and followed by the procedure you want to execute. Okay, so you get the idea, right? So then the thing is, how should I run the program? Yeah, right. So the first thing I just prompt to the user, please press capital A, B, or C, or D. So then we will read from the user, right? So you see your main function here. I move EDX is the prompt message. I write a string. So then I will call read card. So I read the user input. So after I read this user input, they will save in where? They will save in the AL. So now what I will do is, I don't know A, B, or C, or D, right? But one thing is here, the user I get enter from the AL. I just need to continue to compare one by one. Okay? So if that A, I just right away using the code near pointer to execute this procedure. So if not, I jump to the next one. Okay, so that's why here we will have the EBX actually is the beginning where I should check my case table. So actually, like I say, right, I need to compare one by one. If A is not, I go to the next one, I go to the next one, I go to the next one. So on the other hand, I need to have a loop. So my loop actually just confirm is the loop here, I just compare my AL, compare with the EBX. Because AL is 1 byte, so I read the EBX is 1 byte. So if not, I will jump to somewhere to increment my array. So I go back to the L1. So I need to use a loop, right? So the one thing is, the question is, loop, I need to have ECX, right? How do I know my ECX? So if you can see, my ECX actually should be 1, 2, 3, 4. But how do I know the 4 here? Before, when we're using the length of or type, that's because array, they are all the same data type. So we can calculate like that. But now here, how should we do that? So this one is kind of like, it's the object, right? Okay, so here I need to change a little bit. Here I just show you how the case table look like. But when we really run this program, they will look like this now. Okay, I still have the case table is at beginning, declare, and a code, a data label. So I start with a byte A. So then the location for procedure A. So then remember, did you remember this $sign? So this $sign actually means the current location, right? So when I'm using the $sign, I minus the $sign current location to minus the case table. So then the entry size here I got. So this entry size look like what? Look like this one. Did you remember earlier I have the byte A, I have procedure. Actually, this one is the entry size. So if I know the entry size for each set I have, then I know the whole size from beginning to the end. So now when I divide by the entry size for the whole location size, can I get the element is 1, 2, 3, and 4. Right? So that's why we need to manipulate for a little bit. So the first thing I got the entry size. I using this $sign, this after I declare the first byte and the procedure location, $sign minus the case table. So I got my entry size. So after I declare all the elements I want, so then I got a number of the entries. So that means from the case table to the end of procedure D. So then again, you see I use the $sign minus the whole thing. So $sign actually here, the location is here, minus case table. Then this value will give me the whole address for this case table memory size. So I'm using this one to divide by entry size. Can I know the number of entries now? Right, so actually this one is my ECX value later. And also entry size is important. Entry size actually means that each element, how many bytes, right? So this one is later, we will using this one to increment each loop the offset. Okay. So write down any question you have. If you have question, we will go over in the Thursday meeting. Okay, so that's why here you will see now. So we complete the main function. I still write string to print the prompt message. I read the user input. So the EBX is beginning for the case table. Right, so my ECX is the number of entry. So when I compare AL with ABX, right, if they are not equal, right, so I need to go to increment my EBX entry with entry size. So then I go back to my L1 to compare again. So if when I go to the loop, if the if the ECX finish, so I finish the loop, so they will be done if the user didn't give me the correct value. However, if not equal to the user input not equal to EBX, I jump, right? But how about user? Give me the correct value. Right, so that's why I don't jump, right? So after the user give me the correct input, either A, B, or C, or D, I need to code that procedure. So that's why when I code the procedure, I just need to move the EBX by 1. Because one thing is earlier we said, right? Your choice is this one. Followed by the choice will be your procedure location. So that's why here you just need to do the near PTR. So then EBX plus 1, they will get which procedure you want to code. So after you code the procedure, because our output, we just want the user, after user enter A, B, or C, or D, I just print process A or process B or A. So that's why here, after we code the procedure, you can see, for example, if user enter A, so when I code the procedure, I just come to the procedure A. So then I just move the message I want to display for the EDX. So after they done, I still code the right string, so display. But here, actually, this one is a very important thing. How will you make your table-driven selection display? So what you need to do is you need to have this case table ready using the choice first, then the procedure,